Oh, welcome to another week. Nice to see you all in the afternoon today. We had the seminar last week. It seemed to go well. There was a decent amount of attendance there. Lindsay had put up an option for next month. She put up a discussion on what we can do for next month for the seminar. She's not here, so I'll talk through it. But we don't have one to give one next month, but it is December. It's a year-end thing. So she had thought that it could be a good time to have almost like a SimPEG poster session type of thing. Just like if you presented posters over the past year, it's something. Like if you want to share it, you can come and bring it. Not like you have to create something new for this. Just if you've got something to share, let's do it. It sounded kind of like, I think that kind of could be a good thing. Maybe I brought up to her that maybe we could do it like a Gather Town meetup or something, poster session type of thing. So, SimPEG poster session / Christmas gathering on Gather Town or something for those people. But we'll see if you guys have any other thoughts on what to do for the seminar next month. But go ahead and share it in the Slack channels and respond to Lindsay if you can.
Like you wanted to do it in person or?
No, not really in person, just online. Have you guys used that Gather Town app before? So it's kind of like you're an RPG character, like an old 32 or 16-bit RPG character walking around in like a 2D space.
Oh yeah, that thing, yeah.
Yeah. So that's what you can you can share your screen, you can set up different areas, you can talk to people, run around, interact with people as you're moving past them. It's just something. I did a post session much earlier this year that was like that. And I think it worked well. I mean, it was at 6 a.m. or I think it was like 5 a.m., 4 a.m. in the morning or something. So I was really tired, but it seemed like an interesting concept and just something to do. So if you have posters that you'd be willing to share, maybe we can figure out what we can highlight, basically highlighting any kind of research SimPEG posters presented over the past year. So if you have things and you can think about it, maybe Lindsay, as she's coming on, maybe we can set up a list and see if we have enough posters to make something work. Hi, Lindsay.
Hello, I just heard my name. Sorry, I'm late.
I was trying to talk through the seminar next week or for next month, like trying to get a start on that. So I was talking to them about possible poster sessions, SimPEG poster sessions, something else. So any random thoughts that I might have missed? I just don't know what we were talking about yesterday.
Yeah, I didn't hear the beginning, so apologies if I repeat, Joe, but I was kind of thinking, because we don't have anybody lined up for December, maybe just whoever's done a poster either for AGU or something else, show up. We can just have a bit of like a low-key chat. Joe mentioned maybe doing it in Gather Town, which could be kind of fun, because then it's a little more social. You just kind of walk around, see what people are up to, and it's not kind of like we don't have to depending on how many posters there are, like if there's only 3, then we could just do all together. If there's like 6, 7, then we don't want to necessarily have to cut everybody off if there's some cool stuff that you're more interested in checking out and other things that you've heard before and don't need to spend as much time at. So I guess maybe even just with people here, are there posters that people would want to speak to? I know, Joe, you've got one at AGU. Yeah. Xiaolong, do you have one that you'd be game to share? Are you presenting at AGU?
Yeah, I have, but I already presented this part previously in the SimPEG seminar. If you don't mind, I present 10. I can definitely present the poster.
I'd suggest maybe we can get a list going together, people who'd be willing to, and figure out how many we would have.
That sounds great, Joe.
Okay.
Xiaolong, I'd always be happy to listen to you again. And I think, when you got everything in a poster, go for it. 2 thumbs
Thank
up.
you. Thank you.
Nice. Okay. Any other announcements, agenda items people would like to talk about later on after we get through some quick reports? Or just I'll just go right into it. Might as well. Okay, so Xiaolong was able to pulled in my PR for his cross gradient patch, so that will be getting pulled into SimPEG very soon.
Yes.
Yeah, part of that means that we're going to bump it up to 0.16, which means that we are going to be getting rid of all of the future warnings. Because all the future warnings say we're getting rid of them at 0.16, right? All those deprecations that were from the old 0.13 and before. So I feel like it's been about a year and a half since that big transition there. So hopefully we won't rustle too many feathers moving with this change moving. But I just wanted to make a nice warning here saying that this is going to happen.
Joe, will you turn those to errors that still sort of have the same message of like we deprecated this, or is it just going to go poof?
I was planning on just making it go poof, but if we want to actually throw errors, that's okay too. It's just like the point of that would be having better error messages saying you can't use this anymore, use this before it actually goes exactly away. So that could be an option.
I'd be inclined to do that for one, for the next release, or just for one more release, just so I feel like it'll save us answering a ton of questions on Slack.
We can do that.
Good idea.
Yeah, but they will throw errors. The code will not work anymore. Yep. Let's see. I've got EM stuff building, got more GeoSci pages building. So we should be able to get those moving faster if there's any updates to the EM GeoSci.xyz page. It's moving forward. Other than that, I'm involved with a collaboration between the Earth and Ocean Sciences Department and the Music Department here. And I was looking for more auditory aspects to send to them to kind of get an idea of what we do as exploration geophysicists. And I was using the tools that the Aurora package developed, the MT package that they're working on getting data and stuff, to download an MT data set through Iris that was in BC, I think a little bit north of Vancouver, northwest or northeast of Vancouver, somewhere in the mountains. So it's pretty clean data in general. So I downloaded that and I converted it to left, and I have an audio record. I converted it to audio data basically, and so you could listen to what MT data sounds like. And it was a nice thing to do. Also, if anyone has any other thoughts on auditory things that represent exploration geophysics, it'd be interesting to see. I hopefully we'll be able to share that.
Yeah, Joe, can you share that audio file?
I can. Would you like? I can put it up on Slack, and we can.
My MT guy at work here would love to. He would love that.
Yeah, I have it right now with a EX in one channel and HY in the other channel, so you can have your brain do the transfer function.
That sounds cool. I'd be really keen on that.
Yeah, I can drop it in the general channel on SimPEG. 1 second. If not, I'll do that, and we can go on to some other people on dropping it in there. Any other quick reports? I don't see any listed on the notes at the second. Interesting.
Yeah, follow your. Yeah, go ahead, Don.
No, go ahead.
Yeah, just to follow what Joe just mentioned about data. So the last month I attended a competition award, named is FAA. So I noticed in this organization, they shared lots of the data in the different areas. For each areas, they consist of the airborne geophysical data, EM data, MT data, and seismic data, as well as geochemical data. So they all publicly available. So I think maybe it's good for, if you are interested in, maybe it can be used for the research.
Where is that, Shalom?
Yeah, give me a second. I can send a link.
Yeah, put it on Slack. That'd be great.
Yeah.
I dropped it in the random channel on SimPEG, by the way. So you can go there, play it. I'm not sure if you'll be able to hear it, but you can, or if you should be able to hear it. I don't know if I can pipe it in through here. I'll give a quick sample here.
There's some like beat happening at the, what is this?
Yeah, hold on a second. Oh, you're listening to it?
Yeah.
They're like really large spikes. So I'd imagine like maybe it's
Okay.
like far off lightning strike or something, some really short wavelength thing happening.
Sounds like random, man. Sounds like white noise.
But it's just, I mean, it's just kind of interesting. Like, yeah. So, okay, there, you can have fun with that.
Cool.
But yeah, if you guys have any other thoughts, like auditory stuff, let me know. Anything else?
You should put a filter on it, and
Well, this is
I give a couple of versions. Like it seems like completely random.
yeah, I know. This is at least like it filtered out like a very, very, very low wavelengths, enough to where it's like, because like if you look at MT data, like it definitely has a large time, like, you know, daily component that cycles. So at least like trying to filter out the very, very low wavelengths. So this is what it sounds like with it. Like, I'd have to go back and look at it. But I think I filtered out everything below it.
It sounds like you're flying on a plane,
Yeah.
in coach on a plane, just.
Yeah, in the in the with the bags.
Yeah. So, yep, that's interesting. So, Dom, did you have something?
I'm struggling with MT, man. Devon, you were not here last week, but maybe having your, if we want to chat later after this, try to do the forward simulation with topography. And I cannot for the life of me have the E3D forward simulation match SimPEG, or I guess the other way around. The E3D forward simulation makes sense. And if I grab the exact same mesh and I throw it at SimPEG, I just get I get rubbish out. Things are all over the place.
For the boundary conditions, like what was your approach?
Well, right now I'm just using the defaults. What do you mean by boundary conditions?
So I guess to make a source term was always, there's some considerations with that. And I think we talked about it a while ago. One of them was kind of for each vertical, say, set of columns, you would solve a 1D problem, and you'd basically have the 1D solution of the electric field on the boundary, and you could use that to create a right-hand side for the 3D problem. And then Roman had some other technique that I didn't understand very well to basically come up with a right-hand side directly from 3D that you could use when the topography was pretty severe.
Okay, but I'm just using E3D with the 1D connectivity, right? So it should technically be the same. I was hoping.
Oh, so
anyway.
you're just doing like a half space, and you can't get the half space to match.
No, it's a full complex, like a full 3D model. But I was hoping that the forward simulations would be roughly the same, right? Because the L block that you've done, we can get about really close to the same thing. But
Yeah.
anyway, we can talk. Hopefully, if I can get some of your time later to just run through it, that would be great.
Yeah, sure.
Because I'm running out of ideas. I tried a lot of things, and
Really, you have, how much, that's just like a dome you're going over, or? Like I looked at that
no,
project.
yeah.
I looked at
Sorry,
that
go ahead.
project. I looked at that project that I did, and I guess there wasn't like a lot of topography, but like in the grand scheme of the whole thing, but there was topography in it. Seemed to do okay.
Yeah, I mean, I thought so, but if you compare, head to head, same mesh, same model, E3D, MT, and SimPEG, they give like wildly different forward simulations.
Really?
The SimPEG doesn't look right at all. It's like from one station to the other, it's like all over the place.
Weird.
So I don't know. Yeah, I tried the drape straight on surface, maybe even moved them a little bit up, went up to the sky. Nothing works.
Weird.
know.
Yeah, we fed it with a DC inversion too. And,
Exactly. I also use a DC model for it, and then even then, the forward simulation is garbage.
Impedance, or are you doing or
Impedance. Yeah, impedance.
Oh, okay, we were doing resistivity and phase, but
Anyways, that's what I've been up to for SimPEG wise. Yeah. Did you end up, John, finishing the pull requests? Did you do it from tile simulation fork to tile? No.
actually I didn't. Sorry, I'll do that today.
Yeah. Oh yeah. I mean, it's just for you. Cool. Yeah, that's it.
Okay. Any other quick reports?
Yeah, I could do one. I played around, or I was going to play around a little bit with some of the stuff Lindsay worked on with the line source for TEM and things. So one thing I wanted to do basically to test this was take a circular loop and then create a loop out of wires and then forward model both B and DBDT. But I realized that not every simulation class, well, none of the simulation classes are able to actually model both of them. You have either simulations that can model, say, H or B at every time step, or you have ones that can easily obtain DBDT, but you can't really have ones that a simulation that does both, because you would have to solve like a magnetostatic problem at t=0 and then kind of propagate that along. So I guess what I'm saying is we don't have a time domain EM simulation class that works for all receivers. However, we can do a time domain simulation that would be able to work with any data set. You just have to pick the corresponding simulation and receiver classes. So I guess what I'm bringing up is, do we want to make a universal functionality so that every simulation class can predict every single one of the data types, or do we just want to, nudge people towards the correct simulation? It's kind of a question I had for the group. Right now, you just get a not implemented error. It just says, use this simulation, you can model these types of fields.
At this point, I think we should just nudge people to where it's implemented. I mean, sure, we can certainly work on fleshing that out. It's always nice to have extra test cases, but it's not like it's critical. I mean, if somebody needs to simulate B in a time domain simulation, it's possible. You just have to use the correct formulation. So it's kind of like a nice to have, but it's not on, I would say, like a critical path to usability. So in this case, I think, I mean, for the tests, what I think would be even perhaps a bit of a simpler kind of first example would be just to test electric dipoles. So the loops would be good too, but in this case, to test basically an electric dipole either for like E on edges or for J through faces, and test that we get comparable results. That would be a very sort of simple first test before building complexity and needing to actually go ahead and solve the magnetostatic problem first and things like that.
Yeah, because it didn't seem like it was necessary for the stuff that you had just implemented. Yeah, as of right now, though, I was going to, well, I guess, yeah, I'll look around for the different simulations we have, but I'd like to be able to show that if I forward model the data for a loop source that I guess implements the source term as a magnetic source, and then I implement a current loop out of a segment of wires, and in a different formulation, it's being put in as like segments of current. I'd love to be able to get those to match, and that is a good test. But then we could also do one where we compare a electric dipole with the analytic solution of an electric dipole in a whole space or something like that.
Yeah, I agree both are worth having, but I would recommend starting with the electric dipole because it is a simpler problem. And so if you're running into things that are sort of discrepancies between either formulation, because there's a number of things happening kind of under the hood when you're doing a comparison like this. So for the implementation of the line current for the E formulation is that the current is on edges. Whereas if we use either the HJ formulation, the current is going to go through faces. And so we're dealing with different quantities, right? We need to either be like handling edge lengths and things like that, or we need to handle face areas. And so I'd recommend starting with the dipole because it's super simple. You can reconcile sort of the differences in location before then dealing with circular loops where now there's a number of extra things happening, right? Is we're now dealing with a geometry that is perhaps square rather than a circle. And we also have to handle the magnetostatic problem if you're doing time domain. So agreed that both are worth doing, but the electric dipole is a simpler test case to kind of work through any discrepancies you're finding.
Yeah, we'll just sort of do either one of them or both of them, but yeah.
So I was just looking through the fields object again, because that should be what we should tell us which ones are implemented. To me, it looks like if we're trying to get B and dB dt, the magnetic field or magnetic flux density simulations both work for that. Like they both do both of those things. It's just that it seems like when we have the electric field or current density, those two formulations do not support getting either B or dB dt. But the magnetic field and the magnetic flux density both look like
electric field simulation should still support getting dB dt, but it won't support getting B.
Yeah, and the current density one is the opposite of that, from what I remember.
No, both current density and electric field should give you dB dt, but not B, because we haven't solved B at the initial time step. In those,
one of the ways we might be able to get around that, like just temporarily, is to do a reverse integration.
I
Like
I don't like the idea of doing that much because you have to make some assumption about what the field is at the last time.
Mm-hmm.
I don't think that's as stable as doing it from t equals 0.
No, I agree, but like if it's as a temporary thing, it would be an easier one to implement first.
but I also don't really think we need it. I mean, if we've got two formulations that give us B, and if that's what you want, just use that for now.
Yeah, I guess in the end, we're going to end up having whatever you want to model. Ideally, we have the best way of doing it in SimPEG, and there really isn't much of a point in maintaining other formulations that we know are not as good, just so that all the simulations have all the options. So anyway, testing, I could do some testing. Do an electric dipole, try and do a loop thing. Probably won't be that much of an undertaking, and hopefully I'll get on it and have something to show next week or something to say about it.
Sounds good. Any other quick reports people would like to talk about before we call it a meeting?
Where's the link for the sign up for the seminars there? I can probably do January, or I'll sign up for January. I don't think I can make December happen, but January I can for sure. But is that on a Google Doc or?
It is. I can pull that up again.
Thanks.
And I'll drop that in the meeting channel too.
Thanks, Lindsay.
No problem.
Okay. Well, I will then see you all next week. It's nice catching up with everyone.
Sounds good. Have a good day, guys. Good evening.